So in a previous video, I talked about how multiplying complex numbers results in rotation, and that it is taking the angle from one complex number and adding it on to the angle of another complex number. So just as an example here, if I look at and just to remind you, the angles are measured from this positive x-axis and going counterclockwise. So that's just the way that the angles end up working out. So if I had a complex number like, for example, 3 plus 2i, that's a complex number that looks more or less like this. And if I multiply that by a complex number like -1 plus 3i, which is a complex number that looks like this, I know I'm going to take this first angle here, call this angle 1, and I'm going to add on to it angle 2. So I know my answer is going to be somewhere over in this range right over here. And that's just sort of eyeballing it, what we're going to end up at. And just to sort of review how that works, we go this times this, this times this, this times this, this times this. So 3 times -1, 3 times 3i, 2i times -1, 2i times 3i. Remember, that gives you I squared. The only definition of the letter I as a number is its I squared is -1. So we have -3. Combine these like terms to get 7i. 6i squared is -6, because I had 6 times I squared. 6 times -1. Combine those two numbers together, and I get -9 plus 7i. So my angle was a little too sharp. Maybe it's a little bit more like this. I'm supposed to be over here at -9, 7. So you can see this idea that multiplying tends to rotate. So a natural question is, what about dividing? So when you multiply, it takes your angles and it adds them together. So let's see if we can come up with an example of dividing. So I'm going to start with a pretty simple example. I'm going to do 1 plus I divided by... Actually, I'm going to change my mind. 1 plus I divided by -1. Because we know how to divide by a real number. We just do -1 divided by -1, and then we do I divided by -1. So let's look at a picture, see if we can generalize what's happening. Here's 1 plus I. It's got a 45-degree angle. Here's -1. It's got a 180-degree angle because it's pointing due west. Here's our resulting answer, -1 minus I. Think about what angle that one has. That's kind of weird. That has a 225-degree angle because it's going 45 degrees past 180. Or you can think of it as having a -135-degree angle. Okay, that's one example. Let's look at another example. Let's say we did 1 plus I divided by I. Well, I don't really know how to divide by I, but I do know in the previous example how I can divide by -1. So I can turn I into -1. I just need to multiply it by I. Okay, I can multiply it by I, but if I multiply the bottom of the fraction by I also am going to multiply the top fraction by I. So that gives me now, distribute the I on top, I plus I squared over -1. What am I going to do with the I squared? At this point, you should be thinking, okay, I squared equals -1. So I have I minus 1 over negative 1. So that's a negative I and a positive 1. Let's draw our picture. Let's see what we've got. We started with 1 plus I. We also had I. We ended with negative I plus 1. Negative I plus 1 is right down here because that's the same as saying 1 minus I. Okay, so we had a 45-degree angle, and we had a 90-degree angle, and we ended with a negative 45-degree angle. Okay, so maybe you're coming up with some sort of a conjecture here. In example number 1, we did a 45-degree over a 180-degree, and we ended with a negative 135-degree angle. In example number 2, we did a 45-degree and a 90-degree, and we ended with a negative 45-degree angle. Maybe there's some idea coming in mind to you. In the example that I did with multiplication, we had one angle and another angle, and we ended up adding those two angles together. Okay, let's do one last example just to give you a little more variety and show you how you do it in general. Let's say I had, let's do something harder. Square root of 3 plus I divided by square root of 2 plus square root of 2i. Well, this is tricky because the bottom's not a real number. I can make the bottom into a real number, though, by multiplying by something that's almost the same, but not exactly the same. And that thing is called the conjugate. It's the same real number, but the opposite imaginary number. When you're solving quadratic equations, this is how your two answers come. You've got, in the quadratic formula, you've got plus the square root of b squared minus 4ac, and you've got minus the square root. It's the same idea here, that when you have an imaginary number, it comes with its buddy, the conjugate. This is coming from that plus or minus square root. Let's see how things work out when you multiply. This times this, this times this, this times this, this times this. So the top becomes square root of 6 minus square root of 6i plus square root of 2i minus square root of 2i squared. The bottom is where the magic really happens. It's this times this, this times this, this times this, this times this. A square root times a square root will cancel out. So square root of 2 times square root of 2 is 2. Square root of 2 times negative square root of 2i is negative 2i. Square root of 2i times square root of 2 is positive 2i. Square root of 2i times negative square root of 2i is negative 2i squared. Pause for a second. Think what cancels out. Negative, positive. I squared is negative 1. So that's actually counts as a plus 2. So here's what we end up with. I'm going to simplify the top because I don't know some of those numbers off the top of my head. Square root of 6 plus square root of 2 means I've got, if I do that, 3.86. By the way, I made this into a plus square root of 2 because of the same I squared thing. Then I've got negative square root of 6 plus square root of 2. That's what I've got tacked on to the I value. Over here on the bottom, I've got 2 plus 2, which makes 4. So after all this hard work, I can do 3.86 over 4. I get 0.965. And negative 1.03 divided by 4, I get minus 2.58i. So what happened here visually? What happened here visually, let me create a little bit of space. Create a little space. I'll squeeze it in right here. We don't need that part. There we go. Okay. So we started with square root of 3 plus I. That's right here at a 30-degree angle. We divided by square root of 2 plus 2i. And that's at a 45-degree angle. We ended up with something that's really like that. 0.965 minus 0.257258i. And here's the deal. That has a 15-degree angle. How did I get 15 degrees? Well, in all of these examples here, what we've done is top angle minus bottom angle equals answer's angle. 45 minus 180, negative 135. 45 minus 90, negative 45. So here we've got 30 degrees minus 45 degrees, so we get negative 15 degrees. I think I left off the negative there. So anyway, this is a little bit beyond what you need to do in your Algebra 3-4 class, but I think it's still kind of a neat idea. Multiplying means you add the angles to rotate, and subtract, and dividing means you subtract the angles to rotate, which, by the way, should feel familiar. When you were doing exponents and you multiplied two exponents together, you could add the powers, and if you divided two exponents with the same base, you could subtract the powers. It's really that same idea. So in a secret way, something you learn if you keep studying math, complex numbers and exponents are actually really two sides of the same coin. Feel free to ask me if you want to know more about that. Happy to share some of the beauty with you. Come on, computer.